All right, good morning. Happy snow day. This is our first blizzard bag for pre-calculus. I am Mr. McCulley. This is our section 5.3b and it's our snow day presentation. Um, I have no new notes today, so if you get the notes from 5.3 from my website, at shockedandredskins.com, those are the same from yesterday, from what we did on Thursday or Friday. So we're just going to kind of keep moving along here and hopefully get through this fairly quickly. Just going over our goals here for section 5.3. We're going to be solving trig equations using your standard algebra techniques. We're going to be talking about some quadratic type trig equations. We're going to talk about multiple angles. And when I say a multiple angle, it'd be like not just the sine of x, but the sine of 2x, the sine of 3x, the sine of 4x, where you have some sort of multiplier in front of that x. And then using the inverse trig functions. And basically, we're just going to quickly use the unit circle to do the inverse trig function. So we're going to say, what angle measure gives us the sine of, say, that ratio there. So it's not too difficult, nothing that you haven't seen. So today I just have 4 or 5 real quick examples to go over, and then I'm going to give you a couple to do on your own, and that's what we will have for tomorrow should weather change or weather conditions improve. All right, so let's just jump right into it. I start with page 400, number 26, and that one says, for us to solve, the tangent squared of x plus or minus 1 is equal to 0. So when I look at this, I'm going to think of it kind of like x squared minus 1 equal to 0. And I'm going to solve that. I'm going to solve this expression the same way I would solve this simple quadratic expression. I'd add 1 to both sides and then take the square root of both sides, keeping in mind that the tangent, all of those trig functions, tangent function included, are all grouping symbols. So they are at the top of the order of operations. So when we're solving, they are always done last. So just like I would solve this one, when I solve this one, with the only added step is that at the end, I have to deal with the trig expression. So I'm going to add 1 to both sides, and I get the tangent square root of x is equal to 1. And then I'm going to take the square root of both sides. And since I'm taking the square root, I'm going to add plus or minus there. And so the tangent squared x, the square root of that is just tangent x. And the square root of 1 is just 1. So I have plus or minus 1. So it's at this point I have to deal with that tangent of x. Now, basically what I'm going to ask you to do here is I'm going to say, all right, what angle measure, and we remember that tangent is the sine of x over the cosine of x. So what angle measure gives me an x and a y value whose ratio is going to be equal to either positive 1 or negative 1? And that's going to happen right here. My y value is square root of 2 over 2. My x value is square root of 2 over 2. The ratio between the y to the x is positive 1. Over here at 3 pi over 4, I get positive 1, or I'm going to have positive square root of 2 over 2 all over negative square root of 2 over 2, which is going to have a ratio of negative 1. Here, because both the signs are negative, I'll have a ratio of positive 1. And here, because I have a negative and a positive, that ratio will be negative 1. So these angle measures, these 4 angle measures, are going to produce a ratio of positive 1 or negative 1. So my x values that solve this are going to be pi over 4, 3 pi over 4, excuse me, 5 pi over 4, and 7 pi over 4. And those are the solutions to that particular problem. It's not very good for. Let's fix it. All right, moving on. Number 28. They give you this thing. They say 2 sine squared theta is equal to 2 plus cosine theta. Now, this one presents a different problem in the fact that cosine, it has a cosine in it and a sine in it. That makes it a lot difficult to try to solve, to have 2 different trig functions in. But we remember from our trig identity cheat sheet that sine squared theta and cosine squared theta are related. So what I can do is I can take this expression, and since I want to change one or the other, I want to change this sine squared theta into something in terms of cosine. So if I solve this for sine, I subtract cosine squared theta from both sides, and that gives me that sine squared theta is equal to 1 minus cosine squared theta. And so what I can do is I can take this expression and I can plug it in right here. And so I can replace this sine squared theta with this expression right here and call it 1 minus cosine squared theta. And that'll be equal to 2 plus cosine theta. All right, so solving this thing, so let's simplify. I'm going to go distribute the 2, so I got 2 minus 2 cosine squared theta equals 2 plus cosine theta. And we're going to solve this. I'm going to subtract 2 from both sides, and then I'm going to add 2 cosine squared theta, and since they are unlike terms, it's 2 cosine squared theta. Those cancel there, those cancel there, those cancel. And just to reorder, and those are canceled, reorder and make this in decreasing degree order, I have 2 cosine squared theta plus cosine theta is equal to 0. Now this is in quadratic form, and I would think of this like 2x squared plus x is equal to 0, and we can factor that. We can make it x times 2x plus 1. I'm going to do the same thing, thinking about cosine as my x. So I'm going to say that it is cosine of theta times 2 cosine of theta plus 1. And because we want it to equal to 0, what we're going to do is we're going to set each of these two factors equal to 0 and solve them. So cosine theta equal to 0, that one's pretty easy. And then we also have 2 cosine theta plus 1 equal to 0. Have to do a little bit to get cosine theta by itself. Subtract the 1, divide by 2, so I get the cosine of theta equals negative 1/2. And so we're solving for theta here, and I look at these two expressions, and again, I ask myself, since cosine represents x, what angle measure gives me an x value of 0 on this unit circle? And I have 2 zeros for that unit circle. I have it here, and I have one here. So it's these two angle measures that are going to make going to be the values for x that's going to make this cosine equal to 0. And those are pi over 2 and 3 pi over 2. Now for this one, I need to find the two x values where are the two angle measures that are going to give me x values of negative 1/2. That's what it's asking for. So I have an x value of a negative 1/2 here at this angle measure, and I have an x value of negative 1/2 at this angle measure. So the solutions for this second part will be 2 pi over 3 and 4 pi over 3, because they are the two values for theta that will make the cosine equal to negative 1/2. Those are the solutions for that particular problem. All right, moving on to my next particular problem. It is number 36, and it asks you to solve the secant of 4x is equal to 2. Now, remembering that secant is related to cosine by a reciprocal, I'm going to go 1 over the cosine of 4x equal to 2. And I'm going to take the reciprocal of both sides, and I'm going to do that because it's a proportion. And so the cosine of 4x is equal to 1/2. Now, if I pull up, let's see here, I need to pull up my calculator. And smart, yeah, that's what I want right there. I should have had that up before. I apologize. I'm using a trial version at home, so I don't have a good one, but we'll get there. So let's clear out this stuff. Now, if I were to graph just the cosine of x, and we've graphed that a couple of times, excuse me, we see this. Now, what happens when I graph the cosine of 4x? Well, you'll notice that this 4 causes it to be stretched horizontally or shrunk horizontally by a factor of 4. So you can see from that first one, we get 4 times as many of these loops in the same space as we did for just the cosine of x. So the result of that is if I were to graph y equals 1/2, this second graph is going to cross that 1/2 more times. So what we're going to have is more solutions to this particular problem. Now, we want to do it essentially the same way, except we're going to start with 4x and instead of just x. So I say, okay, cosine. Where is the cosine equal to 1/2 on the unit circle? So where's the x value equal to 1/2? Well, it's equal to 1/2 at pi over 3 and 5 pi over 3. Like that. So just real quick, just give me another unit circle. It's a small model here so we can kind of talk about it. And remember, I get 1/2 at pi over 3 and 5 pi over 3. Now, this is where the cosine of x is equal to 1/2. That is not the cosine of x, it's the cosine of 4x. So I'm going to solve this expression just like I would solve any other linear equation. I'm going to divide by 4. Divide by 4 here, divide by 4 here. I get x equals, when I divide 1 pi over 3 by 4, I get 1 pi over 12. And when I divide 5 pi over 3 by 4, I get 5 pi over 12. Now notice 5 pi over 12, it's not even pi over 2. So these first two solutions, they're not even in the first quadrant. And we know that that's to be true because, let's turn this one off here. Because at 1/2, we've got 2 of them, one right here and one right here, real early in that graph. And we're trying to find all of them. So how do I find all of them? Well, I'm going to start using this particular expression, but I'm going to add multiples of full revolutions around and get back to there. So how do I do that? I'm going to go up to pi over 3, and then I'm going to add a full revolution, which is 2 pi. And 2 pi in terms of thirds is 6 pi over 3. That's 2 pi. So 1 pi over 3 plus 6 pi over 3 is going to give me 7 pi over 3. 5 pi over 3 plus 6 pi over 3 is going to give me 11 pi over 3. Now, if I do the same thing, I'm not going to write it all down, but I can see the pattern. So I'm going to have 7 pi over 12, and then 11 pi over 12. And that's not enough because 11 pi over 12 isn't even pi units yet. We've only gone halfway around. And again, we're trying to solve for values all the way from 0 to 2 pi. That's in the directions. And so I add another 2 pi, 6 pi over 3 to both of these terms. So 6 pi over 3 plus 7 pi over 3 is going to be 13 pi over 3. 11 pi over 3 plus 6 pi over 3 is going to be 17 pi over 3. And again, I'll have 13 pi over 12 and 17 pi over 12. Again, we're still not close to 2 pi, so we're going to add another revolution. So 13 pi over 3 plus 6 pi over 3 is going to be 19 pi over 3. And then 17 pi over 3 plus 6 is going to be 23 pi over 3. And so I will get 19 pi over 12 and 23 pi over 12. Now notice, that thing is almost 2 pi. So if I added, excuse me, another 6 pi over 3 to this one, I would be past 2 pi, I'd be over 24 pi over 12. So these are all the solutions for this particular problem. So just kind of like a generalization there. If you have a multiple, if you have a number that's bigger than 1 times x, you're going to end up with more solutions. If it's smaller, like say half x, you're going to end up with less solutions, just kind of to generalize there. All right, number 38. In number 38, they ask you to solve 2 sine squared theta plus 3 sine theta plus 1 equal to 0. Now this is in quadratic form, and when I see something like this, I want to think of it as 2x squared plus 3x plus 1, or my x is my sine. And I can factor this like I would any quadratic that can be factored, and I don't need the quadratic formula. And so I notice that I have 2x plus 1 and then x plus 1. Those are going to be my values that are my factors, and I would solve each of them individually for 0. And so that's what I'm going to do here, except instead of x, I'm going to use the sign. So I have 2 sine theta plus 1 and sine theta plus 1 equal to 0. And I'm going to solve each of them individually. So I'm going to say 2 sine theta plus 1 is equal to 0, and the sine of theta plus 1 is equal to 0. And so solve this, subtract 1, divide by 2, I get the sine of theta is equal to negative 1/2. Just do that right. And then the sine of theta is equal to negative 1. So again, I could think about it in terms of the unit circle. What angle measure is going to give me a sine of negative 1/2? And remember, sine is the y value. So I look for the y value of negative 1/2, and you'll see 7 pi over 6 and 11 pi over 6. So my solutions for this one, theta, is 7 pi over 6 and 11 pi over 6. And then the values, that should be a 6. Let's make that a little bit better. Sorry about that. That's not much better, but we gotta move on. Where is the sine equal to negative 1? Well, the sine's equal to negative 1, and angle only one place, and that's right there. So this one only has one solution, and it is 3 pi over 2. Those are all the solutions for number 38. All right, last one. So when I look at this particular problem, number 44, I check over there on the book, and it asks us to solve for sine of theta equal to the cosine of x minus 2. Now, this particular problem asks us to approximate the solutions using a graphing utility. And there's a couple ways you can do it. You could set this thing equal to y1 and this thing equal to y2 and find the intersections. From 0 is less than or equal to x, actually in this case theta, 0 is less than or equal to theta less than 2 pi. We can do it that way. Or you can solve this for 0 and say 4 sine theta minus cosine x plus 2 equal to 0 and use the root feature, 0 feature actually. And that's what I'm going to do. So I'm going to go to my graphing calculator, go to my y equals, I'll clear out this stuff here, and I'm going to type in the equation that I had, which is 4 sine x in parentheses minus, let's see here, cosine x plus 2. And when I hit graph, obviously that equation is going to be bigger. And I see, remember, 2 pi is 6. So 1, 2, 3, 4, 5, 6. I'm pretty close to 6 here. There looks like there's going to be 2 places where that thing's going to be equal to 0. So go to second, calculate. We're going to find a 0. So I'm going to go 2. Just move my little spider guy. Get a little closer right there. It's pretty good. Hit enter. Move over, hit enter again. And so my first solution, 3.893. And then my second solution, calculate 0. Move my spider guy so I'm close to it. Now a little bit to the left, a little bit to the right, hit enter. And 6.022, and again, that's less than 3 pi, because 2 pi, so less than 2 pi is going to be 3.14 times 2, so 6.28, and it'll give or take a little bit. So 6.022 is our final solution, and that is my last one for the day. So we are finished with my example problems. The practice work will be page 400, numbers 25, 29, 35, 39, 45, 47, and try 71. It's not too bad, and it's just a graph and answer some questions. If you have any questions or if you think I made a mistake, go ahead and leave a comment below this video, and I will see you tomorrow. Good luck.